So this is 1969, number 26. Now, I'll show you things that you could try and you probably would get confused and kind of get stuck. But let's go ahead and look at this. You could say, hey, let's let u be the function on the inside like a u sub. And what's going to happen when you find du, that's going to be your problem because you cannot make this appear over here. You just don't have what you need. And so then you get stuck. You can try to solve for dx, and then you run it in all kind of issues, and you'll find that your u sub doesn't work. And so when you're faced with this on an AP test, now you're like panicking. What do you do? And if it's not u sub, your only other option really is to rewrite. So that's what's going on here. You need to be able to rewrite this in a new way that you're able to do. They're not going to give you something that you cannot do. That wouldn't make sense for them to do that. Then you recognize this is factorable. And it's actually a perfect square trinomial. It factors to that. Then you're extremely happy because this is x minus 1 squared. And when you put it back into the original question, the square and the square root cancel, right? Now we have to be careful here, and I'll explain why we have to be careful. Square rooting and squaring, all of a sudden, things that were okay are now, that weren't okay are okay now. Just gotta be careful. So if our answer doesn't come out, we'll have to evaluate why our answer doesn't come out right. Well, next, we take the antiderivative, which is x squared over 2 minus x, and we use a fundamental theorem. We plug in 1, so we get 1 squared over 2 minus 1. Then we plug in 0, but when you plug in 0, it's just 0. So 1/2 minus 1 is negative 1/2. So to continue on with 1969, number 26, when you square root and square, all of a sudden weird things happen. Because when you square this, it forces that number to be positive. And so something that was negative is now made positive. So this is the tricky part of this question. So this finds net area. If it's above the x-axis, it's positive. If it's below, it's negative. And so this can be negative, right? In fact, from 0 to 1, this is the trick. From 0 to 1, these will be negative. But in this one, 0 to 1, since you're squaring it, it comes out to be positive. So they want to know what this one equals, and it's going to be a positive value, not negative. That's why you ignore the negative, because this one can be negative. But in actuality, because of the square root, this has to be positive, so it's flipped up to the top. It's reflected over the x-axis. That's why it's positive 1/2 c.